Hello everyone, we want to talk about the principle of superposition. Now, we understand that in the last chapter, we talked about Coulomb's law. We elaborated a lot about Coulomb's law, and we got to understand that Coulomb's law is only applicable to what? To interaction of 2 point charges, separated by a distance apart. And we understand that this force that is exists between the two charges is inversely proportional to the square of the what? Of distance separating these 2 point charges, the square, and directly proportional to the product of these 2 point charges. Now, but in this case, we can have more than maybe one charge. We can have like 5 to 6 to 7 to n charges, n-point charges. How do we calculate the net force? Now, what he's saying is simply this. Let me just give you a simple illustration. For example, before I define it, let's say we have Q1. Now, this Q1 I have here, let me clean this, please. Now, as a word, Q2 measure from it, let's say R12. This Q2. I have another one, Q3, measured from it. That means R from R13 from this particular charge. Now we go ahead again. Let's say we have Q4, and from here again, from that Q1, let's say R14, distance of R14 from Q1. Now let me take another charge, let's say Q5, and Q5 now, let's say it has a distance of R15 from Q5. That means all the charges are all measuring their distances from Q1, which is our specific charge. That means we want to actually consider this as our reference charge now. Now, this charge, so what superposition is saying is that the force, the net force on what? On Q1 is equal to what? The electrostatic force experienced by what? By all other what? Charges, individual charges. The force that will be acting on this man. So that means the net force on Q1 now is, which is the specific charge that we are talking about, is this vector sum. Vector sum, that means F12, F13, F1, that means force of this one on this, F14, then force of Q5 on Q1, F15, and so forth and so on down to what? F1n. That is to say that the force, that the electrostatic force experienced by Q1 is the vector sum of all other forces, Q1, Q2, Q3, Q4, Q5. What that is acted on it. You understand? That is what this particular one, this one is talking about. That means you are going to sum other forces with reference to this Q1. That is what superposition is talking about. So it now states that what? That the force, electrostatic force, experienced by a force, a specific charge, Q1, let's say Q1, is the vector sum of what? All individual what? Charges, the force produced by all other what? Forces acting on that particular Q1. So in this case, now if you want to write it, we can write it like this. You can say Q1, Q2 over what? R12 squared plus KQ1, Q3 over R13 squared plus KQ1, Q4 over R13 force squared plus, put an absolute there. Absolute, if you are not using an absolute, I will tell you what to do. Then K and so forth and so on. This is what? 1, 2, 1, 3, 1, 4, 1, 5. Q1, Q5 over R15 square. Then you can go ahead to what? Plus dash 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 to what? KQ1 QN over R1N square. So you can go ahead to what? To keep summing them together as long as the number of forces given in what? In the question. As far as the number of questions given in the question, the number of charges that are acting on this. So what is now saying is that what? That the principle states that the electrostatic force acting on what? On a specific what? Charge, which is let's say Q1, say Q1 in this case, is the what? The vector sum of all other individual what? Force of other charges. You can say forces, individual force on it by other charges. So you see now, that is what the theorem, that is what is stated. Is saying that what? That the principle states that the electrostatic force on a specific charge, let's say Q1, is the vector sum of all other individual force or forces on it by other charges. So in that case, now we check. We can write this particular one in a what? Let's say the net force can also be what? The sum of what? Starting from I equal to, let's say 2, then down to N of what? K Q1, no, Q what? I all over what? R1 I. So this is it. So this is a what? Representation of the vector or principle of what? Superposition. Sometimes you can see write it like sum of what? From I go to 2. You see this one can be 2, 3, 4, I. Now it can be 2. This is 1. So don't forget this is I. So this is 1. So 1 is our reference charge that all other forces are acting on. So don't forget that. Then another way you can write it, you can say Q what? KQ1 QI over R, the square here, please. R1I square, then put vector, unit vector there. That is another way you can write it. So that one will also indicate the direction. Because sometimes this one is talking about only the magnitude. It's not indicating, this one indicating direction for us to be able to know which direction is it heading, the net force. So we must be able to know. Don't forget, force is a vector. So we must be able to know the direction in which the net force or the forces are acting. So that is just that. And one other thing you must have in mind is that force is inverse equal to what? Inverse equal to what? The square of distance apart. That means the closer the distance, the higher the force. I repeat, the closer the distance of two charges, the higher the interaction between them. So if I have, for example, now I have what? Okay, all these charges now. If I should ask you, which of them has more influence, more force based on distance apart or their distances apart? Which one will have more effect or higher force on Q1? It's Q2. Why? Because Q2 is what? Having a closer distance compared to what? Other distances that is of Q1, Q2, Q5, Q3, Q4, Q5 from Q1. Their distances are very far, or they are very what? Large. But in terms of Q1 to Q2, their interaction between Q1 and Q2 be more than interaction between Q1 and Q3, and also Q1, Q4, and so forth and so on. So these are the basic things you need to comprehend, so that as we enter the next version of this explanation of superposition, it can be very clear to everyone watching this video that it is very easy to solve problem on superposition. Now let us take an analysis. Let's take an analysis of what we are saying so that we can comprehend it better. We have just explained superposition, but let us apply it. I think in that application, we will get a clearer picture of where we are going. Now let's say Q1, this is positive Q1. Let's have what? A negative Q2. Okay. Then let's say we have a positive what? Q3. Now this is negative, don't forget. Can be positive. So this one is R12 from here. Then this is what? R13 from the Q3. Now, having known this is a system, now we want to calculate, they say what? Find the what? Net force on what? On what? Q1. We want to find net force on Q1. Now, there are some basic things you need to comprehend, that you need to understand. Don't forget that when two forces, according to vector, which is the vector sum, if you check the definition, that's why I see the definition there. It's the sum of all what? Is what? Is the vector sum of all other individual forces on it by other charges. So these charges, all other charges, are creating a force on the charge that we are focusing on. Now we want to calculate the net force on this. So we need to consider when two forces are moving in the same direction, or two vectors are moving in the same direction, because the force is a vector, we add them together. But when they are moving in opposite direction, we subtract. So these are the things you are going to have in mind. So in that case now, this one will now be what? Plus and minus. Plus minus. So this one will what? Attract. That means with a force F12. Why will it attract? Unlike charge attract, while like charge repel. So this is unlike, positive and negative. They are unlike charges. So automatically means that it will what? The force of this Q2 on Q1 will be towards this direction. Now, what about Q3 on Q1? That is the question. What is the influence of Q3 on Q1? Now, because the two of them are like charges, it will ensure that the force on Q3 on Q1 will move like this. It must be along the line. You understand me? So that is the direction in which you go, because they are like charges, so it will repair. Just like this one will repair. You understand? Just if you remove this one now and you place these two in the field, this and this, they will repair each other. If you place these two in the field, they will attract. This one will attract towards this. So will attract towards. But we are not concerned about this. This is not our major target. Our major target is we know that this one is also F12, and this one is what? This one is also F13. But they did not tell us to calculate net force on Q2 or Q3. We are calculating net force on Q1. And since we are calculating net force Q1, the net force will now be equal to, now they are moving in opposite direction. So what do you do when you have two vectors moving in opposite direction? You subtract. But the question is, which one do you subtract from which one? Now, F12 is greater. F12 is greater than F13. Why? because F1, the force Q2, the charge Q2 is closer to what? To Q1. Let me use a magnet for instance. If you place a magnetic substance very close to a bar magnet, it will, the more it will want to attract itself to the magnet. But when you move it further from the magnet, it will tends to what reduce the attractive what influence on that bar magnet. So that is it. Now this one will now be F12 is greater than F13. So F12 minus, because the bigger force minus smaller force. And why are we subtracting the vector for this? F is F13. They are moving in opposite direction. So F13. And this one has smaller distance compared to this one has bigger distance. So the one with smaller distance have the higher force. The one with bigger distance of separation between Q1 and itself is what? Lesser force. So this one now will not be what? Q1, Q2 by R12 square minus what? F1 what? 3 will now be what? Q1 absolute Q3 all over R13 all square. So with this we can get our what? Net force. But let us see how can we get the net force on, let's say, okay, let me calculate if I calculate the net force on Q3, I think the same thing. I want to look for a case where we can have addition, we have gotten subtraction. Now let us see this. Let's see this one. Let me clean this. Now I'm look at this now. Let us see a case where we can have something like this. Let's say Q1, let's say Q2 and Q3. Let me make this one plus. This positive. Q2. Let me make this one what? A negative what? Q3, Q1. And let me make this one what? Positive what? Q3. For instance, let's say the distance between here is R12 and this one is what? R23 is 21, 23. Now let's have, we want to illustrate this one, want to analyze this now. Now in this analysis, I want to find the net force on this one, on Q2. I want to find the vector sum on Q2. Vector sum on Q2. I want to follow me. Now, this is positive. This is positive charge and this is negative. Now, if we compare this, now let me say R23 is greater than R21. That means the distance between what this one is larger. Let's say here, for example, 10 meters. Let me use that, can always have it in mind. Let's say this one is 2 meters, for instance. So that the distance of this one is bigger than this one. Now, which I want to just analyze. Now let's see. Plus and minus is what? They will attract. So this one will move towards this direction. Don't forget, we are looking for net force on Q2. Then this will also attract anyway. There will be an attraction of that one too. They will attract each other. Then between this and this, they will what? Repair. So that means this one will move like this. On this, this is what? F12. Let me clear this one. This F12 or F21. Then this one, because this is positive, they will repair. So in that case, you want to go this direction again to continue. That means this one will make the Q2 to move away. So this one will create what? F23. That means we now have what? That means this one will make the Q2, the charge Q2 to move this way. Then because this one will move like this one move like this, they will repel. Then due to negative and positive attraction, it will also attract towards this side. So we now have how many forces are moving in this direction now on Q2 is what? Q2 will produce two forces moving in this direction. So that means F1, 2, 1 and what? That means, look at it. So F21 and what? F23 are moving in the same direction. This is what? Like the Q what? Q2 now. So that is the force it will create, moving in the same direction towards the left hand side of what? If I'm standing like this. So now the net force now will now be equal to what? F23 plus F21. Now I have added. Here I subtract. I subtracted here. Here I added the values. Why? Now, when two vectors are going in the don't forget, force is a vector. So if two vectors are moving in the heading towards the same direction, what you do is you add them, all the forces, all the individual forces together. But when they are moving in opposite direction, you subtract the smaller force from the bigger one. So it now be bigger minus smaller, like what I did in this case now. But in this case now, because they are moving in the same direction, and the question, the structure of the questions, of the question that we see on the board are allowing movement in the same direction. Why? Positive and positive. This one will repel like this, one will go like this. Because they will repel each other. One will go like this, one will go like this. So the one going this way now is created by this man. Look at it here. Q3 created this force moving this direction. Now Q1, because it's a negative charge, is going to attract this man towards this side. So making two forces in this direction. And since they are going the same direction, all you do is to add them together. So you are going to have what? K, Q2, Q3 divided by what? R23 square plus K, Q2, Q1 over R21 square. So this will give us our net charge. So you have to be very careful of how to go about your resolution. So I will give you one assignment to resolve the force for me. Let me give you something like this, okay? You send it to the comment section. Let's say minus Q1, Q2, this is Q2 is for minus, and Q3 is also what? Let's say minus. Now this is what? Let's say R12, R13. Now what I want to do for me in this case now is to send your answer to the comment section. What will be the net force on Q1? What will be the net force on Q1? Because in my next class, I will want to take more questions. I want to take questions on this aspect that we have learned. Don't forget that you must consider the sign before you can know the direction, positive and negative. That's why this one will create this force moving towards each other. Although we are not considering this, then considering positive and not positive here, Q3, though they are far, which makes the force less. So they will repel, this one will repel like this, while this one will go like this. At the end of the day, the effect, at what effect or direction have they created on Q1? They are actually moving in opposite direction, which implies that what? That the bigger force will be 1, 2, because the distance is small, while the smaller force will be what? 1, 3, which is distance is far. So we now what? Say 1, 2, F12 minus F13. Then you can now put the what? 1, 3 between charge Q1 and Q3. You apply Coulomb's law. Now apply Coulomb's law. So Coulomb's law will also help us to be able to bring out our formula after doing your subtraction of forces. This is Coulomb's law now. This is Coulomb's law. So you now subtract them together by using their charges. So same thing with this one. This one is just an addition of forces. This one is subtraction. What we did here was addition of vectors. So the vector sum resulted to what? Addition of what? Of this what? Forces. Why this one is what? Resulted to what? Subtraction of what? Of vector. Subtraction of vector, which is all the forces here. So you can now see that when we say vector sum, the vector sum is what? According to vector analysis, when you are analyzing two vectors and you discover that they are moving in the same direction, you have to add them together. But when they are moving in opposite direction means one is towards the left and the other one towards the right. What you are supposed to do is to pick the smaller force, remove it from the bigger force, and whatever your answer is your final answer. The only thing is that any answer we are going to get here will help us to design the nature of the reason. Because if I want to ask you what is the nature of this force now, if I ask you now what is the nature of this force here is going to be what? Attraction. Why will it be attraction? Anytime you have an attractive force, attraction, it will always be what? Minus sign. Attraction, anytime you have a minus sign, maybe I have minus 2.0 Newton, for example, it shows that this thing is what? 2.0 Newton attraction. But anytime I'm having positive sign, it means repulsion. In my final answer, maybe you are not using magnitude format, you are not using this absolute, and you are just solving them directly like that, and your answer gives plus, you know that the portion dominated the system. This is a system of three charges. Now don't forget, now in this system, if I should ask you which one will dominate this system, which one dominated which force has more influence on Q1? Is it attractive force or repulsive force? The answer to the question is attractive force. Attraction force dominated this system. Why? Because Q2 on Q1 is creating an attraction and is closer to what? To Q1. Q3, which is supposed to be repulsive force on Q1 because of like charges, is far away, far distance from Q1. So in that case now, in this system, if you want to solve without putting an absolute and you solve directly, you will end up having a negative sign because of what? The negative sign will indicate that the system, the nature of the particular the force acting on Q1. Then the same thing you can also examine here. When you solve and you discover that, okay, this one now is more or less like summation of what? And it's moving towards what? Negative. So that means negative dominated this particular system. For it to be moving in the direction of what? Of the negative sign. That means the result will be what? Dominated by what? The negative direction. Because this one now will face more of this one. So, but question can better be explained by when you are summing two vector forces together. With question, you can be able to know. But for this one, take note of that. Whenever you have a negative force, it shows attraction. You can say 2 Newton attraction. Whenever I have what? Positive, maybe I have what? 2 Newton. This is what? Positive 2 Newton. That means 2 Newton repulsion. So, but we are going to talk about more of this in our next class. Ensure you stay tuned and subscribe to this channel to always get notification about any class that we posted on this channel, and also to be able to follow up what we're going to do in the next class to comprehend better what we have done in this class. Thank you very much. God bless you. Have a wonderful day.